Modern power grids are more reliable because they combine multiple types of generation to make sure that power is available when it's needed. As BWL transitions to increasing reliance on renewable sources, new high-efficiency gas turbines will play an important role in power generation. That's why Delta Energy Park is a huge addition to BWL's portfolio.
Here at Delta Energy Park, we had a lot of intentional, innovative design choices that helped us to keep our costs down by varying and reducing the cost of overhead with our buildings, also the safety functions of reducing buildings, and keeping the plant able to be able to produce safe and reliable power for our customers.
Lansing's new Delta Energy Park took 1.4 million labor hours to create, which included laying 30,000 cubic yards of concrete, 10 miles of mechanical piping, 20,000 miles of electrical cabling, and involved 20,000 hours of operator training. At the heart of Lansing's Delta Energy Park sit 3 Siemens SGT-800 turbines. These turbines were large enough that they had to be specially transported and carefully built into the plant building structure. When generating in simple cycle mode, these turbines will load up to 171 megawatts of power, and when in combined cycle, up to 250 megawatts of electricity. At Delta Energy Park, the whole process starts with clean pipeline gas coming into DEP's compressor building. Here, 3 compressors take the gas from 350 pounds per square inch in the pipeline up to 500 pounds. Compressing the gas adds heat and increases efficiency in the Siemens SGT-800 turbines. Only 1 compressor will be needed to run the system on a typical basis, so the additional compressors provide operational redundancy and maintenance flexibility. Compressed gas then runs in a pipeline underground. Gas continues to DEP's gas conditioning area. Here, the gas for 2 of the units is heated to 484 degrees Fahrenheit. While all 3 turbines can run off the non-heated gas as needed, heating improves efficiency. Gas then flows into the combustion gas turbines. Here, the big reactions happen that generate power for the grid.
So what you see behind us is the heartbeat of our Delta Energy Park plant, is our combustion turbines. How this works is we draw in clean natural gas. At the same time as we're sucking air through the intake for the gas turbine, we're squeezing it down as it runs through the compressor. From there, the gas is then met in the fuel valves in the combustion chambers, creates a spark, we have a bang. That's what spins the turbine up to 6,600 RPM and turns the generator on the back end at 3,600 RPM. Units 2 and 3 are the combined cycle portions of the plant. What they do is they take the heat exhaust that blows out from the gas turbine, and we use that in a boiler and create more steam that goes through a steam turbine for additional megawatts. The simple cycle portion back here is left over for any of the peaking power that we may need, or also in the event that we would need spare parts for one of the other units.
2 of these 3 generators operate on a regular basis, while 1 sits on standby, spinning up quickly to meet the needs of BWL customers. The 2 primary combustion gas turbines are what's known as combined cycle units, meaning that the hot exhaust gas from the combustion gas turbines is used to produce high temperature and pressure steam from a heat recovery steam generator to drive a steam turbine generator. Each heat recovery steam generator can produce up to 280,000 pounds of steam. These HRSGs are also closed-loop systems, recouping close to 80% of the steam. Cooling towers facilitate the cooling of the plant circulating cooling water, which is pumped over the tower, creating small water droplets, while fans draw air into the tower, cooling the water. This is also a closed-loop system that the plant monitors, closely watching out for things like water pH. Maintaining a closed-loop system helps reduce waste. All controls at the plant are centralized, safe, and efficient. Everything in the plant can be operated remotely from the control room, with the exception of gas compressors. Those have to be locally started and stopped for the sake of safe in-person monitoring of those processes. The gas turbines each have an individual control room. They can be started and stopped locally, but this is more for emergency situations. All this power goes out on the grid. DEP feeds 13.2 kilovolts out to step-up transformers that takes it up to 138 kilovolts. This power is also backfed and stepped down in order to provide power to run the plant itself. Just in case, a 0.5 megawatt generator is also on standby to power emergency lighting and fire pumps in the event of power interruption.
DEP represents a combination of well-tested technologies and also industry's first, working with different vendors from overseas. Obviously, through the COVID-19 pandemic, created a lot of obstacles for us. The site had to shut down for a couple days, and we had to regroup and figure out how we could get the work done, being creative with social distancing methods that were never factored into the project. The beam up here in white is an opportunity for everybody in the company to be able to get a chance to sign the beam before it's raised as the top steel for the project. With this one, obviously, there was a dedication to the 5 individuals that lost their lives October 3rd of 2019 when we had a plane crash, and also we had a young lady who had a fatal heart attack on the project. In honor of her, we added a 6-star above the aux boiler stack. The project had a lot of obstacles to go through. At no time did the team's commitment ever waver, and we were able to persevere through and complete this project.
To learn more, visit lbwl.com.